Hello, and welcome to CDCon 2021. In this session, we will discuss Project Shipwright in depth. My name is Adam Kaplan. I'm a software engineer at Red Hat and a maintainer of Project Shipwright. I've spent the past 5 years building applications on Kubernetes, and before that, I helped companies ship freight containers at a logistics-focused consulting company. With me is Enrique Encalada, a software engineer at IBM and a fellow maintainer of Shipwright. He has spent the past 4 years improving the experience of developers on Kubernetes. So yesterday, hopefully some of you attended Jason Hall's talk where he introduced Project Shipwright and gave a high-level overview of Shipwright builds. If you were unable to attend, I encourage you to watch the replay, as this talk will assume you understand the information Jason presented. Today, we are going to dig under the surface and reveal the technical details of how Shipwright builds work. I'll start with the anatomy of a build and explain how Shipwright builds run on Kubernetes. Using this information, Enrique will then demonstrate how you can write your own build strategies, showcasing new features that are currently under development. So, to understand how builds work, think of the build API as an onion. Onions have layers. Container images have layers. Shipwright builds and the Shipwright build API also has layers. We'll start with the outermost layer, the build run. In front of you is the simplest kind of build run you can create, and yet it has all of the information Shipwright needs to extract your source code and assemble a container image. This is because the build run only has one primary job: to tell Shipwright when to build a container image. Where your source code is and where you want your image pushed to is in the next layer of the API, the build object. So let's peel back this layer and take a closer look at the build object. Here we define where the source code is located, where we want to push the image, and which strategy we want to use to assemble the image. You can see this particular build is cloning source from GitHub. Since no branch or tag reference is provided, the source is cloned from the repo's default branch. Likewise, the image is pushed to Quay using the latest tag based on the image spec we provided. We also specified that the build will use the Conoco build strategy, which is available across the entire cluster because it is a cluster build strategy. This doesn't tell us anything about how the source code will be assembled into a container image. For that, we will need to reveal the next layer of the API, the build strategy layer. So let's peel it back once more. Now we're at the innermost layer, the build strategy. In front of you is a snippet of Conoco's example build strategy, which you can see in full detail on Shipwright's GitHub repository. Conoco is a tool published by Google that can assemble an image from a Docker file within a Linux container, like one that runs on Kubernetes. Here we outline the steps needed to build and push a container image with Conoco. A build strategy consists of one or more build steps. Each step has a name, a container image reference, a set of commands and arguments, plus a few more options. Most developers using Shipwright will not need to inspect the details of a build strategy. The Shipwright maintainers catalog build strategies for common image building tools like Conoco, Builda, and Cloud Native build packs, which can be added to your cluster after installation. Engineering team leads and maintainers of image building tools, however, may wish to write their own build strategies. Let's see how the build run, build, and build strategy objects come together to build a container image. In my terminal, I am connected to a Kubernetes cluster running on my home lab with Shipwright installed. On the right-hand side, I'm going to watch for build run objects. And on the bottom, I'm going to watch for Kubernetes pods. Let's now create a build that uses the Conoco build strategy. You can see that I already have the Conoco strategy available as a cluster build strategy, which means I can use it in any build or build run. So let's create a build that uses the strategy. You can see that in this particular build, I'm going to push to quay.io. And because this is using my account, I have to provide credentials via a secret. This build is also going to clone source from GitHub. And since this one's public, I don't need credentials. So let's go ahead and apply this YAML. And you can see just because I have applied the YAML, created the build, doesn't mean that I am creating a container image. In order for me to create a container image, I have to create a build run. So let's go ahead and create one. And this is the simple build run that I showed you earlier in the presentation. We'll apply the YAML. And now we are on our way to creating a container image. You can see up top, we have our build run. It has the succeeded state as unknown because, well, we are running our build. Below that, you can see that we have a pod. The pod status is currently not ready, but clearly something is going on here. The question is, how did this happen? How did Shipwright transform the build run, build, and build strategy objects into the pod that you see in front of you? If you look back, you may have noticed two things in my previous slide. First, as you can see in the highlighted sections, the build step API looks a lot like the Kubernetes pod spec API, particularly the containers array. Second are the two values for the working directory and the destination argument. These look a lot like Tekton variables used in Tekton tasks. And this is not a coincidence. Our Onion API in Shipwright is used to generate a Tekton task run with an inline task specification. The task run, in turn, creates a Kubernetes pod whose state is reported in the task run status. Shipwright reads the task run and combines its status into the build run status. Let's go back to my terminal. This time, I'm going to watch for Tekton task run objects on the right-hand side in the center pane. You can see from my previous build that there's already a successful Tekton task run with the reason succeeded. Let's create another build run, this time using the ship command line. Ship is a utility that makes it easier to interact with Shipwright builds. It is currently under development, and we hope to publish its first release soon. This command will start a build run from the reference build and will follow the logs once the build run starts. Notice that when I start the build run, the Tekton task run object is created. Its status is reflected directly in the build run status. The task run, in turn, reports its status based on the underlying pod state. Now that the build is running, you can see the logs stream back to my terminal, with each step highlighted for readability. What I demonstrated only scratches the surface of how Shipwright uses Tekton to run container image builds on Kubernetes. In the next section, I'd like to pass the baton to my fellow maintainer, Enrique Encalada. Enrique will show you which Tekton features will be utilized in the execution of a build and how you can incorporate these features into your own build strategies. Take it away, Enrique.
Right, so thanks a lot, Adam, for the nice explanation. With all of those details in mind around build and build runs, now let's take a look on the details behind build strategies. So I would like to do a quick deep dive on, all of the concepts behind the strategies, so that at the end of this call, people will be able to build strategies in an easier way, or also to achieve optimal strategies for building their container images. There are 6 concepts today behind strategies that I think are important for people to understand. We have the scope, we have steps, basically what can I define under the strategy, how can I use the steps. We have something that we call today system parameters. We have also all of the different tooling, which is all of these tools that allow us to build container images inside Kubernetes. And then we have 2 new features that are going to be available soon in the next official Shipwright release. This is the strategy parameters and the results. So let's speak a little bit about the scope. This is really simple. We have 2 types of a scope, a cluster scope and a namespace scope. The difference is like the first one makes the strategy available across all of the namespaces in the cluster. The second one is just for a specific namespace. Keep in mind the kind is different depending on the scope you would like to have. The next thing is the steps. The steps are kind of the core behind the strategy, as a step defines the behavior of that particular strategy. Typically, in Shipwright, we define strategies with a minimum amount of steps, usually 1 or 2. And steps have two main key points. The first one is that the steps are basically going to be executed sequentially. So you can define on the respect.build steps multiple steps, and all of them will be executed one after each other. The second one is that the content of each individual step is really analogous to containers in Kubernetes. So if you take a look behind the object of a step, you will find basically the same Corby one container object as in Kube upstream. So depending on the use case, you can use fields like resources to constrain the execution of the step, security context, and so on. In this particular example, what I have is a cluster scope strategy called builder with a single step called build and push. And this step basically is looking for a path to the source code and a value on how to call the image I want to push. This basically means to which registry host name, registry namespace, and image name. The second thing is in Shipwright, we have been doing a lot of effort to keep the definition of strategies as simple as possible. We are in the business of building container images, and obviously for build a container image, you need source code. What we try to achieve is that users that define strategies should not take care too much on how to make sure that the source code could be available in their step definitions. And also they don't need to develop any sort of binary to make sure that they can pull source code from an external artifact, in this case, Git. We provide under the hood all of the steps that they need to have so that they can pull the source code. So when they define their build and push step, the only thing they need to know is how can I reference the path to the source code that is located on this particular step. If you will try to do that through Tekton task runs or a pod in a vanilla Kubernetes cluster, the complexity will definitely be higher, as you need to do first ensure that you can run the container sequentially, and then you need to make sure that you can share data between the two containers. The next thing is system parameters. As I said before, we make sure that on your step definition, the source code that you want to build a container image from is already available there. You just need to know where is that stored. And we achieve that through system parameters. System parameters are basically reusing the Tekton feature about parameters. You could see like the notation to define parameters is the same as Tekton. It's basically params followed by the name of the parameter. In this case, we have today 3 in Shipwright, and in this example, I use 2. I use source root and output image. System parameters are usually prepended by SHP, which stands for Shipwright. And what I'm simply doing in this example is I'm telling my step to look for the source code under the source root param, which is going to give me a path to the source code in this container. And the second thing I do is I use the output image, which is going to give me the value on where to push that image I want to build. Strategy parameters are similar to system params in a way that they use the same feature from Tekton, which is parameters. But strategy parameters are basically parameters that the user needs to define in advance. In this case, it's the same example. I define a new parameter called registry insecure, and then I define a new flag on my binary definition that uses the registry insecure flag. This basically allows this strategy to decide if this container image should be pushed to an insecure registry, or if it should not be pushed to an insecure registry. The default behavior is false, but the strategy parameters allow users to modify that behavior. So I can usually have to the right a build that reference this strategy, and through that build I can modify the behavior by changing the value of registry insecure to true, which basically means that on the execution of the build run, this strategy will try to push the image to an insecure registry. Tooling is really important. There are 2 things behind tools. You need to understand why you need to use a particular tool, and then you need to understand like all of the details behind the tool to see if there is like any feature that you can take advantage of. For example, if I would like to have a container image built from source code that have a notion of a Docker file, I will probably use Canicom build kit. If that's not the case, I will probably use buildbox. The second thing is like I know that Canicom build kit have nice features that allow me to generate the digest of the image into a file, or also that allow me to have a caching functionality. So those are definitely things that you want to keep in mind so that you can understand how to use them when you define your strategy. Today in Shipwright, we have 6 default tools, the ones I list here to the left. And for each of these tools, we have an independent strategy definition. The last thing will be surface results. This is a feature that is not yet in place, same as the strategy parameters. And surface results basically reduce the feature from Tekton around results. And in combination with the tools we use, we can make sure that valuable metadata will be surfaced to our build runs once they run to completion. So for example, if I just build a container image, I should make sure that my build run knows about the container image digest that I just generate. That's all for now. Let's move to the demo, and I will explain here how to use these concepts in practice. Basically, what I'm going to do is I will show you that I have already a build, right, in the dev namespace. This build is called BuildKit build, and that reference a BuildKit strategy name. So let's see how can we apply those concepts I mentioned before in the definition of this strategy. So we're going to modify the strategy now, right? But first, let me explain you what is happening here. The first concept is the scope. This is a cluster scope strategy, and that's why I can access that from my dev namespace. The second thing is like the strategy have a single step, and the idea behind this step is that it should build and push a container image. For that, I defined BuildKit. This is the tool of choice that I will be using. But so far, on the execution of this step, nothing is happening. So let's modify this. I would like to show you now how can you use system parameters or what are the contents behind them. So let's make sure that we can show that. Let's quickly do something like this. We save this one. And then what we're going to do is this. I have a script running in the background that is going to generate a build run and it's going to send the steps logs to standard output. Okay, so again, we define a strategy with a single step, but at runtime, we have 2 steps, source default and build and push. So this is the nice thing about Shipwright, that Shipwright will prepend a step for you that will make sure that the source code is available to you from this repository into the next step. You don't need to worry about the source default step. That is something that happens under the hood for free. The second thing is system parameters. So on the step definition, we need to know where on this step I have the sources and where I want those sources to go in the form of a container image. So if you take a look on source root, which is a system parameter, you will find this value, which is a path to this step. Source context is the same case, a path on this step where the sources that we want to use for build are. And then output image is basically the value on where should I push this image, okay? We're going to modify this one more time, but now we're going to use the definition of the commands for BuildKit, right? So I have this one here. So let's do that. We need a pipe here. Let's make sure that is inline. And then we will also use results. Keep in mind, results is not available today in any of the official releases, and also the API may change, but I just wanted to use this for educational purposes. Again, what's happening here? So I'm using the BuildKit scripts available under the image of BuildKit, and BuildKit asks me for 3 things. It asks me for where is the sources context, so I use the system parameter. Where is the Docker file, which happens to be on the same path, so I use the same system parameter. And where you want this image to be pushed, so I use the other parameter, which is output image. We tell BuildKit to pull to not to pull to an insecure registry, and also then we use the Tekton feature about results, so that we can populate a result called SHP image digest. And I will tell you in a minute how this one is how can this one be very helpful. So we save that, we go back here, and now we see the logs again. So let's take a look on the new build run. So the build run is an unknown state, so it's actually on the process of building the container image. And the build and push step is already using BuildKit to build. So eventually I get access. I basically successfully build the image and push that to my registry. Now, I spoke of results. You can do something like this to get basically the digest of that image that we just pulled. And you can basically use that digest to pull the image here in my local machine. Okay, so that's really awesome. Let's move back to the presentations because this is all for the demo. The next thing is a call for action or join us. We have community sessions every week or community meetings. We have a lot of docs and examples for you to try out. And if you want to reach out, just don't hesitate to do that. We love to hear from you. We are available at the Slack under the Shipwright channel. And also we have a Twitter account, Shipwright.io. That's all from us. We're really happy to be here. And now let's open the session for Q&A.
All right. So I'm Adam. I'm hoping the polls poll should be open. We've got 6 votes. And Enrique's here too.
Hello, folks.
I don't know if we need to relaunch the poll. All right, so we've got about 5 or 10 minutes for any question.
Oh, there is a question.
All right. Oh. Maybe Enrique, can you read it? Since it doesn't seem to be showing up for me.
I think it's not yet available. I think Brian said he have a question, but he haven't put it down.
Okay. We'll give Brian a moment.
So let me just, I think the question is available. Brian says, my understanding is that this gives us the best of Knative and building persistent container images. I think so. I think like definitely we have a nice story for building container images. I think one of the core features of Shipwright is that we have what we call an extensible framework. So basically, depending on the type of source code that you need for building an image, you will basically get from us a large catalog of images that are already well known in the Kubernetes landscape, and you can easily choose on which one to use for building the type of source code that you have. Usually, when I refer to type of source code or flavor of source code, it's usually source code that have a notion of a Docker file as a way to dictate how to build that particular image. But also we have situations where we just have source code, and the best choice there usually is build packs. Yeah, not sure if you want to chime in there, Adam.
Yeah, I think the only thing I could add there is one of the more interesting things I've observed is frameworks that are and tools that are more opinionated for the language, and they're focused on specific languages. So build packs is that first kind of like framework where it lets people create packs that can work with either like Go, Java, Node.js, Ruby, and so forth. But then you've got even more specialized ones like Jib and Co that are really tuned to just one programming language, one way of assembling things. And they all work inside of a container, which historically has been very hard to do. So that's something that we certainly feel like there's going to be more of that in the future, and we want Shipwright to be a place where those things can come and be distributed in the hands of developers.
I also find interesting that Brian mentioned Knative. I mean, the only thing I could say on relationship with Knative is that today, for example, you can allow an integration where you have Shipwright as the block that is building the container image, and you can definitely integrate that for with something like Knative, which will be like the block for deploying that particular container image. So I would say like Shipwright definitely complements a full end-to-end story in a Kubernetes cluster.
I'll be perfectly honest. I wasn't as familiar with Knative build when that project was going on. I guess it might have been 2 years ago, 3 years ago. And sort of, I know some of the Knative build ideas got built into Tekton, and for us, a lot of actually the original impetus for Shipwright came out of OpenShift builds, where we had our own sort of like build API. And so what we wanted to do is take the lessons that we learned from OpenShift and apply it to a broader context and allow it to be used on any Kubernetes. And things have kind of evolved from there. So if we have gotten ideas from Knative or we've put it in through osmosis, I think those are all good things.
Yeah, it did, definitely.
Shubik has a comment about we could probably have integrations between Knative eventing and triggering of Shipwright builds. So one actually thing that I've noticed on this particular CDCon is there were some previous talks around the cloud events and cloud eventing, and that's something where I think could be a lot of area for collaboration, not just between Shipwright and Tekton, Shipwright and Knative eventing, but just sort of in general having an ecosystem where different things can be event based and can talk to each other through this sort of unified interface and specification. So that's something that I personally am looking forward to coming out of this year's CDCon.
Yeah, I can just add like there is so many use cases for events that we can consume through Knative eventing and then make it available for triggering build runs. Like for example, Git webhooks have all of these different actions on what happened in your GitHub repository, from pull requests that get merged to issues that someone opened. So that definitely is something that Knative eventing can support today, and that together with Shipwright, that could also be a good story for someone.
Yep. Another thing that's worth mentioning that we have either it's some R&D or a proposal that's out there is to integrate Shipwright with Tekton's custom task feature. So in that case, you can create a run of a custom task, and then Shipwright would understand that. And so that could also be another integration point between Shipwright and Tekton. Brian has another point. The point of Shipwright is to build persistent images, whereas Knative is a framework for running code to run applications through code.
Yeah, I think we haven't touched actually too much on the topic on Knative and Shipwright integration. Like so far since the inception of the project, we have been really focused on, making Shipwright just do one type of job, which is building container images. But just going back to the question, is Shipwright, envisioned to build persistent images? I think so. I think that's a good way to describe that.
Yep. All right, we've got about, I think, 1 more minute left before our time's up.
Yeah, maybe we can quickly just speak on why to use Shipwright and not to do this through, like a Tekton task, which is probably one of the questions that a lot of people will have. Yeah, you want to go ahead?
Sure. So this has actually come up in conversation at work with other folks who are looking at Shipwright, looking at Tekton. And so one thing that I like to create an analogy to is sort of, if you think of CI as like sort of a Swiss Army knife, Tekton as a whole is, you could think of it as like the casing that lets you have a bunch of different tools. Each task that you might have in a catalog could be one specific kind of tool. We envision Shipwright as being like the corkscrew, where it's just one thing that has its one specific job, and it does it in one very specific and opinionated way. You could certainly do almost everything that we're doing in Shipwright with either a single Tekton task or multiple Tekton tasks chained together. But we want to create an interface where it's a lot simpler experience, where you know what you're getting in, and you know what it's going to be executed. There are some things that we're doing in an opinionated fashion, like obtaining source code, but then there are other things that using the build strategies, you as a developer or a team lead or someone who's managing a development organization, you can provide to your developers.
Yeah, maybe just to add on top of that, on a different topic, like who is using Shipwright today? We have Shipwright as the de facto build service on one of the IBM cloud services, which is called Core Engine. So we chose Shipwright to do that type of work.
And likewise, a long-term vision for Shipwright is that we would be able to provide that as a service on top of OpenShift. This is from Red Hat.
So how is the poll going, Adam?
I think the poll might technically be closed. So we have small sample size, but we have 1 vote for local computer, 6 votes on CI system in general, only 2 votes for on Kubernetes. Oh, now 7 votes for on our CI system.
And just I think like as a general message for the folks on this session, like don't hesitate to reach out to us in case there are questions from the talk. We're more than open to welcome you on any way possible, from community meetings or just opening an issue or just ping us on Slack.
Yep. And speaking of that, I'm going to post links into the chat. We have our main docs website at shipwright.io, and we also have our community GitHub repo where we have links to join our mailing list, our Slack, as well as links to our public calendar. And there we go. There's the community link. All right. If there are no other questions or comments, I think we'll let folks head out. I believe there's another slate of talks happening at 4 p.m. Eastern.